All right, ninth graders, so I am going to keep that same sheet of paper we were just using, where we've put all of our problems on, and we are going to go to the back side where you had numbers 9 and 10, and we are going to do a couple different examples on there, and I'm going to show you what that looks like on my screen here. So give me a second, it's taking a long time to switch. Okay, you should be able to see my camera now. So these top two problems are up there. And hold on, I'm gonna turn my fan off and let me. Okay, hopefully all distractions are gone now and we can get going with the math. We are gonna look at a couple examples of graphs and you're going to tell me what sorts of transformations occurred. So the first graph that we're going to look at, we'll label that top section and we'll just call it, I don't know, I'll probably just call it graph number 1. All right, so I put graph number 1 here, and now I'm actually going to show you what graph number 1 looks like. So on the first graph, it looks like this. Okay, so we are looking at a graph where I started off with the pre-image points, and I can tell over here that these are the pre-image points because A, B, and C do not have the prime tick marks on them. But then over here, A prime, B prime, and C prime do have those prime dashes. So how did I go from ABC to A prime, B prime, C prime? Was that a translation? Was that a reflection? Was that a rotation? So let's talk about those. A translation would be like if this were a sticker and I could slide it and then slide it down. Now, if I were to slide it twice, would it land perfectly on A, B, C prime? No, because you see how it's like pointing down? Over here, it's now pointing up. That means it changed the way that it was facing. So a translation is not going to work here. Let's think about a reflection. Reflection seems like a decent idea at first thought because I've got A, B, and C, and when it's pointing down, if it were to reflect over a line like this, hold on, like a slashed line, then it would be pointing up after you flipped it over, which seems really good actually. There's one issue with that. Look at where A started. Now, where does A prime end? That's the problem. Because if we were to reflect this, A would not land on A prime. It would land on B prime, which means that this was not a reflection because corresponding parts would not line up. The same parts that A does not line up to its partner, A prime. So this is not translation, it's not a reflection. That means that this had to have rotated. So this thing rotated and it could either go over the top or down below the bottom. I'm just gonna draw it over the top. You'll notice it doesn't matter which way you draw it rotating. It would still land in the same place. So if I could twist this around the origin, notice A is over here on the left and it would end A prime up here on the top. It would end in a half circle. B would do the same thing and C would do the same thing in the middle. So what I'm going to say here for what happened in this picture for graph number 1, I'm going to say rotate because I've got to be specific. And then how did it rotate? It rotated 180 degrees. Now, did it go clockwise or did it go counterclockwise? It's a great question. Think about that clock and think about what 180-degree rotation would look like. If I were standing in front of you right now and I were to spin 180 degrees and you were to close your eyes while I spun, when I was finished, my back would be toward you, but you wouldn't necessarily know which way that I spun to get there. That's because there's nothing like proprietary about spinning 180 degrees. No matter which way you turn, you end the same way. So it actually doesn't matter if we say clockwise or counterclockwise. I'm gonna leave it blank. I'm just gonna say rotate 180 degrees because we don't wanna waste pen ink, I'm sure. Okay, so you wrote rotate 180 degrees. The other thing that I want you to do on these graph problems is write down what the mapping would be. So for rotating 180 degrees, it would start with our XY mapping. Then I'm gonna check back into my notes. I actually still have my note card handy. Excuse me, I've got the hiccups. So 180-degree rotation is this green one here. xy maps to negative x, negative y. I want you to start getting so familiar with those mappings. All right, let's go on to graph 2. Graph number 2. All right, on graph number 2, it looks like this. We have A, B, C, and it maps to A prime, B prime, and C prime. Okay, so how did I get there? Was this a translation, reflection, or rotation? Did this slide, did it turn, or did it rotate? Wait, hold on. Those are the same thing. Did it slide, did it turn, or did it flip? Okay, so A has to get down here to A prime, B to B prime, C to C prime. Ninth graders, this was just a slide. That means that this was a translation. I'm going to start by writing translation. Now, that's not enough. You have to also say where it translated to. So I'm going to look at A, and I know that A has to go to the right and it has to go down. So I'm going to draw in how far to the right it has to go. I drew a little arrow like this. Now, how many spaces did that arrow go? 1, 2, 3, 4. So I'm going to write a 4 there just so I don't forget. So it went 4 spaces to the right, and then it goes down quite a few spaces. If I were to count that, that is 9 spaces down. So where it says translation on my paper and on your paper, because you're writing down everything I write down, I'm going to write translation 4. Actually, I'm going to write right 4, down 9. Both of those things are part of the translation. I don't know why I drew an arrow and boxed it off there. It was because there was scribble and it made me uncomfortable, so then I started drawing other stuff. So just make sure that you have the word translation and then the directions for going to the right 4 and going down 9 spaces. Okay, let's write our mapping for this one. I start with x comma y, and I draw my arrow, but I'm going to go back to the note card that I had a moment ago. You'll see this on my note card. X plus right, x minus left, y plus up, y minus down. So if I'm going to the right 4 and down 9, right would be adding. And since I'm going to the right 4, I'm going to be doing x adding 4. And y is going to deal with this down 9. Down is subtracting, so I'm going to say y minus 9. And that's all for that one. That is graph number 2. All right, let's move on to graph number 3. This is what graph number 3 looks like. Ooh, I love graph number 3. Okay, let's write it down. Graph number 3. Okay, so we've got A, B, C, D, and A prime, B prime, C prime, D prime. Try to think about that one. What happened here? How did we get from the top image, top pre-image, to the bottom image? Was that a reflection, rotation, or translation? Now, my favorite mistake on this one is when people call this a translation. That is actually a mistake because remember back to what we said before, A starts here, but if I tried to just translate it straight down and bring this whole box down, A would land on top of C prime. That's not what we want. We don't want A in the top left corner of the final image. We want A down here to become A prime. So how does A turn into A prime? What does it have to do? Well, if I tried to rotate it, it would end up like over here. So it's not a rotation. This one's a reflection. Now I'm going to take a marker. I'll use yellow. And let's figure out what it reflected over. It's going to stay that same distance from the line of reflection. And you can see it's almost perfect. Well, it is perfectly reflected over that, the x-axis. I can tell because I can count up 1, 2, 3, 4, 5, and I can count down from the line of reflection 1, 2, 3, 4, 5. A and A prime are both the same exact distance from that line of reflection. So my answer here for number 3 on graph 3 would be reflect or reflection over, and then I'm just going to say x axis. Reminder, I know it's the x-axis because of this thing right here. It says x. So reflecting over the x-axis, if I go to this list, xy maps to x, negative y. So I'll write that mapping down. X, y maps to x, negative y. All right, your job now is to do the rest of the examples that I linked directly below this. I put pictures of each of the graphs, and your job is to try your best on them. I just want you to try. I know some of these are difficult, but you're still gonna try even the difficult ones. Do your best and follow along to get the rest of the practice in.